Hello, everyone. Welcome to Mining Now. I'm your host, Jerrod Downey. Today, we are doing another episode with Glencore Technology. We had a great episode last, I believe it was at CIM. We filmed the episode, and now we've got them back on the show, but from a different side. Everyone, welcome to the show. Great to have you on.
Thank you.
Thanks for having us.
It's great to be here.
Yeah, let's start with where are you doing the interview from? I'm here in a studio in Vancouver. Where are you located?
We're located here in sunny Brisbane, Australia. So right now it's heading into the hot season for us, whereas for you guys, it's heading into the cold northern winter from what we know.
Yeah, well, I'm in Vancouver, so it's just heading into a lot of rain. Cold
No,
and
that's
wet.
true. We've got one of our guys based there in the Vancouver office, and no, it's true. There's no snow there, but the other Glencore divisions on the other side of the coast in Canada, they're the ones that get the cold snow.
The cold, yeah. And lots of vitamin D sales go up. I imagine in Australia, it's not a hot commodity.
Actually, you'd be surprised. Everyone wears so much sunscreen, they don't get enough vitamin D, so it's still a hot commodity.
Well, there you go. The two companies are working in cahoots. No. Okay, so everyone, welcome to the show. It's going to be lots of fun having you on. The last show that Scott did, we're going to switch it up to a different side. We're going to really be talking about the extractive processing side. Stanko, can you just give us a summary of some of the things we're going to be covering today?
Oh, definitely. So you're right. The last session that we held with you guys was all about our minerals processing technologies. And really now what we wanted to give everyone a feel for is that next step after you've made the concentrates or been able to process into a semi-finished product. And that's where it leads into the part of the business I look after. And I've got Laurie and Rebecca here with me. They work on this area every day with our clients. And really what we're looking at is being able to take those concentrates or products, and in this case, we're going to talk you through today our hydromet side or the Albion process. It's about leaching them into solution and then being able to extract the value. So we look after the base metals, the precious metals, and really there we're looking at being able to take those into the next stage of production. So it may not yet be the final metal product. It may be still, if we look at the battery industry, it's a battery grade product, which is an intermediate that goes into that process. So really that's what we're all about, is being able to take those products from our minerals processing colleagues and really take them that next step into production.
And where did the technology start? Where did it get its legs?
Oh, that's a really interesting question. And for us, when we look at how long Glencore's been involved in hydromet, it's been probably since the inception of our operational areas and sites. And one of the big changes that happened for us was the development of the IsaMill. So that was commercialized in the early 90s, and that was the first time we had an ultra-fine grinding mill within the actual group and within the world when it came to application to the mining industry. And with that development, we were able to apply that to the hydromet area. So Glencore pretty much started working straight away to be able to look at using that technology to feed into how can we actually look at accessing ores through the hydromet part of the space. So the key concept that was able to be addressed there was being able to get a very fine particle size to lead into you being able to leach it into solutions. So we started looking at basically high impurity containing copper cons in the beginning, all internal to Glencore. And then through that, when it came to looking at where it would be applied, Glencore was looking at the other aspects. We pivoted to zinc, and that's really where the technology took off. And for us, that was about the 2005 mark. And that's when we started looking at actually applying the technology even externally to Glencore. And interestingly, that's about the same time Laurie and I got involved in the actual mining industry itself. Yep. We sort of pursued our careers within that sort of space. For me, it was in the extractive side within the high temperature space, and Laurie was within the Townsville assets looking at the hydromet space. But for us, that was, for Glencore, that 2005 point was where we started looking externally where we do use the technology, but still internally as well. We had 3 installations in Glencore that we put out there. So within the zinc space, that was at Asturiana de Zinc site in Spain, Nordenham, within Germany, as well as then looking at our own operations here in Australia at MacArthur River. Now, externally, we were developing it not just in the base metals, but in the precious metals. And that's where 2009 and 2013 was where we adapted it to the Las Lagunas site, which is in the Dominican Republic, and then also at Geopro Mining, which is located in Armenia. So it was really taking that technology out there into many different parts of the industry.
Mm-hmm.
Pretty successful commercialization over, I mean, I guess it's over years, but in the scheme of things, not that long of time. How many I don't know if I'm at liberty to even ask this, but I'll give it a shot. How many installations have you had since sort of those first ones?
Oh, that's a great question, because for us, like, we got to that point, we commissioned a couple of plants then even in 2013, 2014, and we sort of saw it as now as the point we've sort of skipped past, or we've jumped across the divide the chasm that you have in terms of technology development. We commercialized, it was under development for 20 years, and we were there being able to actually bring it to market. And we had a lot of clients and projects at that point where we were looking at adapting it to copper and other base metals. But if we look at what happened at that point in time, we haven't had any other big installations of the technology. And it's really quite an interesting factor when we look at that as to what happened. And it's more something that didn't actually affect just the Albion process, but it affected the hydrometallurgical industry as a whole. Like, if we look at what was happening then, China was establishing itself as one of the other smelting hubs of the world. And so therefore they were taking in as many of the materials as they could. They were competing with India, with Japan for the toll smelting market. And then that really dropped down the payment terms for any concentrates that were made. So when you look at a mine that was looking at developing through us, our minerals processing technologies back then, you look at 2010 sort of mark, they'd pretty much all be speaking to us on the Albion side as well. But when it started looking in midway through that decade, that sort of started to drop off. But we could see it, the incentive there to actually make more than an intermediate product, more than a concentrate financially, it was hard to justify when it could be sold for, the majority of the metals payable content for those sites. And so when we look at what was happening then, we hit that point, and the whole hydromet industry had no installations after that point in time. Now, we understood this. We saw it coming. We then saw an opportunity to look at technology development. And within Glencore, we worked on, where could we develop this? And we targeted the regions where, by the jurisdiction, the government has mandated that you got to produce metal in country. And if that's the case, then that meant they had to do something. And that's where we got involved. We had our Sable Zinc operation, which was then commissioned in 2017 for copper. And we were then also looking at other aspects within the Glencore group. So really for us, it was working through clients and projects and justifications, but it was a quieter time for the technology as we sort of worked through that period of those low treatment charges.
So it wasn't really like a competitor thing that getting it to market. It was more the environment then.
Yeah, that's exactly right. Like, you look at all our marketing from back then, we were still comparing ourselves to pressure oxidation and showing how much we were lower in capital in that, and to bio-oxidation more flexible in that. But really, that wasn't the competitor. Nobody was building any hydromet plants. Our real competitor was the fact that it was making concentrate, and that being treated by the smelting market of the world. And so really we had to pivot ourselves. And it's really quite an interesting thing, because we could see it happening. Of course, the projects were stopping at this point. So we had to really look at considering, let's look at recycling. Let's look at these harder to treat complex feeds. Let's look at what else is there that can then take advantage of all of the development that we've done.
If you're treating refractory gold or complex ores, then you need How to Leach Difficulty or Varying Feeds and Recover More. It's packed with cases and papers on Albion Process leaching technology. But it also has the world's first online calculator. It's free, and you'll learn what CapEx and OpEx you'll need for Albion Process to treat your feed. You need Albion Process to liberate your refractory locked gold. To get your pack and use the free calculator, click the link in the description below.
So now we're at a point, now this is, when did ESG really become a focal point as well? And I'm sure that must have tied in to the adoption of it into the market as well. Is that right?
Definitely it has. I mean, when we look at we had Laurie and Rebecca coming into our group here. They were in different parts of the industry. Laurie was at Murrumbidgee site in Western Australia as part of the Glencore operations there. He came across to us at GT. We sort of realized that we needed to build our team, and it was all about the fact that a lot of the companies were focused on the environmental side, and then that fed into the whole ESG area of looking at sustainability, governance, and what actually we're doing as mining companies to give back to communities. And we'd seen an uptick in the amount of clients that were coming to us and asking us to help them, even with what we call green, clean concentrates. And really, when we started understanding that, it was that, hey, there's something more at play here. We could see it in the annual reports. People were looking at analyzing their Scope 1, Scope 2, and Scope 3 emissions when it came to CO2 that was being generated. There was a real push, and I think as that was brought on by probably the global community, looking at where do they want to invest their money, and they want to make sure they're investing it within companies that want a sustainable outcome. So that's something that I think has been key to us being able to go, hey, we need to take into account our environmental impact, our social impact, and when you look at any company that's processing in country, I look at some of the projects that we've been involved in, where we've built plants at those sites. It's really improved the community. That means there's investment there. That means that companies are being able to bring forward schooling in hospitals. It's really then allowed them to be able to focus on the give back. And that's really key with that ESG commitment that many companies have. But for us, when it comes to that, we look at what companies are really interested in now. And it's something that I think we've seen in the past 2 years, is this focus. We've got companies, even Glencore ourselves, we've set our target at 2050 for net zero. But we've also set targets for getting to that. And then there's intermediate targets, 2026, 2030. And a lot of these are about dropping emissions, being able to show that we're doing the right thing by the community. And when we consider it, the key one for us, I think, is the Scope 3 emissions, because that's where we look at the end product usage and the CO2 that's generated from that. So if you take a gold con or if you take a copper con and you ship that to one of the hubs of the world, you have to actually absorb all the CO2 that they're spending or using to be able to treat that material and make a final product. And then you have no control over that in some extent when it comes to where that's traded. So now companies are looking at taking that step forward and going, hey, I want to get in control of this. I want to actually be able to look at doing this. And that's where, from the hydromet side, it's really been key for us. And I guess that's one of the key reasons I've got Laurie and Rebecca here. I know they've been a bit quiet for the first part of this interview, but really it's about them talking through a lot of these projects we're working on, and where we've seen the key application of Albion. And really that's something I think we can really help a lot of people understand to then look at when they think about their projects and the opportunities that are there.
Actually, hi, Laurie, Rebecca. Thank you for. We kind of wanted to cover everything on that intro here, and then pivot into some very real world applications, some of the technology a little bit more. Rebecca, we're going to start with you. Can you talk a little bit more about just taking us through those initial stages of the Albion process and walk the audience through the process?
We're walking through the process or the actual Albion. So the Albion process itself comprises two very simple steps. We start with ultrafine grinding and lead into oxidative leaching. So for us, the process begins with how we work with our clients initially to actually understand whether it is suitable for them. So I am in a very fortunate position where I oversee all of our test work and the early stages of engineering with our clients. So I get to see a lot of different projects coming through. typically we are starting off by working with potential clients to understand their need. We'll have a look at their con specs, have a look at a preliminary flow diagram to see how we might treat that con, and understand the potential viability of our process for that client's project. So what we're looking at doing here is giving a very early indication as to whether this might be viable for them, so they can make some informed decisions straight up when they're doing a technology review as to whether this might be right for them.
Just on that point, what sort of separates out what will be viable and what will not be? What when you're testing it, what's the information coming back that says yes or no?
Well, I guess that's completely project specific, isn't it? So depending on what target extractions we might have, as well as constraints around the project, whether they be technical or economical, that's going to determine, I suppose, what the cutoff point for a no or go is going to be. So looking at that, what we...
Can I just jump in?
Please do.
I was just going to say, we do have some like really high level test work at this stage that we approach every project with there. And that's really a pass fail type test work program that we run through, where we, I suppose you could say we hit it with everything that we've got in terms of grind size and oxidative leaching. And if it works, then we say, yes, this is a potential. But at that stage, if it doesn't work, we can say, you know, Albion's not necessarily the answer for this project. And then from there, if it is successful, then we can start to look at, you know, how is it most successful, I suppose.
How we can optimize it to suit their needs.
And sorry, before I jumped in, that's where you were going, Rebecca, is that next, like, okay, how do you optimize it now once it's viable?
That's exactly right. So we'd start off initially with sort of very high level amenability test work leading into class 5 engineering. So what we're looking at doing here is just ascertaining, does it work? Yes, no, as well as some additional data that we would feed into that high level engineering study. So the objective here is to, as quickly as possible and with as little outlay as possible, give our potential clients an indication of whether it is going to work. So evidence the viability of it and the economics behind it, so that they can quickly and efficiently make decisions on their end about whether this is a process that's worth pursuing for them.
I might just jump in there. I mean, one of the key things I guess we always get asked is what's the sample size? And we say, oh, it's a kilogram. And you know, for an operating site, that's nothing. But if you're developing a project, I mean, that could be $1 million worth of drilling and float work that you might need to do to get that. So I think that's the key thing when we look at that test. It gives that answer quickly for the smallest amounts of mass possible. It's a kilogram, right?
Yeah. Kilogram of con, and we get a surprising amount of data from that kilogram of con. So we are sort of making best use of what is a bit of a precious resource, concentrate, particularly for greenfield sites.
Right, and that is the key, that you're testing concentrate. So this has already been refined to a point where the testing, it gives you a very clear answer. Is that right?
Yes, that's right.
What are I want to look at it from the client's point of view. What are some of the challenges that they're encountering or that you're encountering in these conversations? Could you sort of just walk us through those?
Absolutely. So I suppose looking at it, we've got both technical and economic challenges that we'll be dealing with, and they will vary and be quite unique project to project. From a technical perspective, at the moment, what I'm seeing a lot of are a lot of complex concentrates coming through for testing. So typically concentrates that have high levels of impurities in them that make that sale to a smelter quite difficult. Either the levels are so high it's impossible to sell it, or the sale of those concentrates would attract quite a high penalty associated with their sale. So we have clients coming to us to seek a way of actually separating those impurities from the target metals of interest, and certainly the Albion process is capable of doing that. A lot of these concentrates at the moment are copper concentrates and gold concentrates that have high amounts of arsenic in them. So clients coming to us to look for a way to remove that arsenic from the economic mineral. And in the case of our process, we leach that, and it is converted to a stable species that can be directed to the tailing storage facility, whilst the target metal can then be directed to downstream processing.
sorry if to the audience that are experts in this is an obvious question, but is this a system that can be integrated into existing, or is this sort of key at the greenfield stage?
No, it can be applied to both brownfields or greenfields operations.
Okay.
So existing operations, certainly, and greenfields in the initial design as well.
Yeah, I'll actually add to that and say that this is one of the things that makes like our suite of technologies quite good. We can, I suppose, implement it in a stage-wise manner. So we can implement, say, a concentrator early on, and then generate a concentrate for sale, and then come in later and look at it. And look at installing an IsaMill and oxy-leach reactors as part of the Albion process. So no, it definitely doesn't need to come in at a greenfield stage. But in saying that, even if it is greenfield, it doesn't all need to be installed at once. It can be done in a stage-wise manner to stagger that capex over a period of time.
Yeah. I actually don't feel like now that was a terrible question. It seemed like, but Rebecca, you mentioned that it's sort of unique to every project, and Lori and Rebecca, please jump in together on this one. But does the technology change? Is the use of is it more about making a case study for that this is good use in this particular application, but the technology is very similar, or is actually the technology itself being adapted for specific operations? If that makes sense, the way I'm asking that question.
So if I've understood correctly, the actual process itself at its core will be the same. So as we said, the two key stages, the fine grinding and then the oxidative leaching. I suppose the difference is in the sort of the sizing of the equipment and the parameters at which we run the process. So yeah, scaling, that's right. So it will vary project to project. The process through which we evaluate whether the Albion process will be viable for a particular operation will be tailored uniquely to each client and each of their projects as well. I don't know if you wanted to add more to that.
No, I think you covered it, yeah.
Yeah, I think from my perspective, when I look at it, it's a lot of our clients get to the point where they realize that, hey, this could be a leaching hub for the particular materials that they have. It always starts with one side.
Yeah.
They come to us with the problem child and they go, hey, can you help us work out a solution for this? And we help work out that solution. But then they start thinking, oh, hey, this is a very simple approach to the system. Oh, if you add in this con or this other feed that we make or this, middlings con to free up capacity in the concentrator, and then we can work through that and go, it's the same system. We might need to add another tank at the end to account for another point in the resonance time to meet that requirement, and then that's it. But the system as a whole, it's really quite advantageous to have that modularity and that flexibility for that approch.
Yeah, that's right.
Yeah, and you mentioned the problem child, and my problem child is I like to take everybody off on tangent. So I don't want to skip over some of these challenges because they're quite important to cover. And Rebecca, I think there's a couple more that we wanted to make sure we looked at.
Oh, I just flagged before that we do see, I think with any project, economics is, well, we know it's always a consideration, and for some projects it is a big challenge. So we see a lot of different concentrates come through, and obviously they vary in terms of the commodity of interest that we're targeting. They vary in terms of their grade. And from the perspective of looking at treating, in the case of Albion, a sulfide, or what we're looking at, it's not just about the grade of the metal of interest, but that grade relative to the sulfur content of the concentrate as well. So what we're looking at here, we're looking at what do we need to spend to oxidize those sulfides to gain that contained revenue that's indicated by the grade. So more and more, I guess, as demand for certain commodities is increasing, we're seeing lower grade cons, or lower grade relative to sulfide content or sulfur content starting to come through as they become potentially more viable to treat. I think that the appeal of the Albion process, stemming from what you were saying before, is that it's sort of its simplicity and its flexibility. It means we typically come in at a capex or opex that's about 30% lower compared to other processing options. So that's just further increasing that potential to treat those deposits that historically may not have been considered economical to treat. Okay,
this is a good spot to pivot into my favorite way of saying it is to bring the audience into a real world scenario now. So can we start, can you we put something together there for the audience to understand this application in that real world capacity.
Yeah, absolutely. So yes, I realize it's very easy to throw around percentages like 30% less capex and opex. But
Yeah.
So for a bit of context, I guess on probably one of the most recent class 3 or feasibility studies that we've just completed, just to give some concept to those percentages, if we're looking at a gold processing plant, so an Albion plant, for a throughput of about 15 to 16 tons per hour, you're looking at a capex of about 100 million USD. That was your project. So I will hand over to Laurie just to give you some information or discuss that case study.
Yeah, that's right. We had a client approach us last year, I think, initially, and I've worked on their project, and I worked through that initial pass-fail type level of engineering, and we progressed through that and now into the feasibility phase of that engineering and test work.
Laurie, can you take me back to the beginning of a project like this? What are the initial, when the client is coming to you, what are the conversations? What are they asking? What are you having to provide in those initial stages? I'm talking right in the first, days and weeks.
Yeah, of course. So in a lot of these deposits that our clients are working with, they have a lot of gold that's contained in the oxide portion of their deposit, and over time they work through that oxide portion of the deposit, and they start to see more and more sulfides, and the gold's then hosted in those sulfides, and that tends to be quite refractory material, meaning that the normal gold processing technologies won't work to extract that gold. So that's when they start to come to us to look for a sulfide processing technology, and that's exactly what happened in this case.
So, okay, so when you get into we've already covered a bit of the testing part, but how does in this particular case, where does the testing results feed into the actual design and the process that you then end up recommending to the client?
Yeah, so I suppose we take those test work results and after the initial stage, and we move, as I said, into the feasibility stage of the test work, and we start to refine that test work. By that we mean we look at how much do we actually have to grind it? We try and sort of minimize that to save sort of capex and opex on that grinding portion. And we also look at how much of that sulfur we actually have to oxidize. And that's where a lot of these capex savings come in as well, because we unlike some other technologies, we don't have to oxidize all of the sulfur that's present. So we do the test work to work out how much of that sulfur that we have to oxidize, and then essentially we stop there. And that means it decreases the amount of oxygen required, which means it decreases the oxygen plant size that's required. So
I suppose that's sort of in terms of that. I guess the key here is that we are starting with test work and we are sort of progressively refining it. We start with just can we? Yes, no. So people can make a really fast decision as to whether this process is going to work for them. And if it is, and there is potential economic viability there, we're going to move into later stages where we're going to optimize those parameters so that we can lower the capex and opex. And from there, we take that data and that provides the underpinnings for the whole engineering study.
You already touched on it a little bit, but I wanted to sort of expand on it. And anybody who wants to answer this. Now, is this primarily for gold recovery, or is it in a lot of the base metals that is applicable?
Well, I mean, the one I'm looking at is a gold project, but no, Albion Process is definitely can be used both in the precious metals and the base metals as well. So I suppose I will actually sort of points come to mind that it's probably worth talking about that Stanko touched on before, and that's this hub style plant that we're seeing that the Albion Process is actually a really good answer for that. And what I mean by that, I suppose, is they always start with the problem child, as Stanko said, as we would like you to design a plant that will deal with this ore. But then as time goes on, they start to move through that deposit and they say, well, we've got this deposit as well. And then potentially other third parties might come and go, we can only make a concentrate, and you take it from a concentrate through to a final product. And that's where the Albion Process is really good because of how flexible it is and because of how easy it is to adjust how it operates. It can take really variable feeds and process it and still get really good results. And that's not just in the gold space, but also in the base metals, space as well.
And I guess when we look at the project that we ran for this particular client, that first con that we treated, I mean, it was pretty much perfect for Albion.
Yes, it was, yeah.
But then what we realized is that, working with them, with the Albion to keep the pH, we need to neutralize. And then we sort of realized, well, what other ores do they have that might have within them an agent that we can use instead of purchasing limestone or something else to neutralize? And that's where, working through all the other options. I mean, I think you did a couple of tests in a few of the other deposits they had, and we actually found like this ultimate combination where we could get really good outcome from them.
That's right, we did. So yeah, as Stanko mentioned, we because the process generates acid, we often have to put a lime-based neutralizing agent in to neutralize that acid. But we had a look at their different deposits, and we found that one of their deposits had a lot of acid-consuming gangue present in it. So we were able to come up with an option where we utilized that acid-consuming gangue in place of the lime-based neutralizing agent.
Wow!
And that meant that they could decrease their OPEX, and also a lot of sort of logistical issues were sorted with that as well.
When we talk about real-world scenarios, are there any other projects, as we went through the last one, that sort of stand out to you to go, oh, we should cover that in reference to the technology?
We are moving into feasibility work for a project, so the Hudbay Copper World project. Now, the Copper World project involves it's a resource of 1.2 billion tonnes at about 0.4% copper grade, so it's a decent size. But this one's particularly interesting because the project will involve mining from several different zones. So we'll be working with a number of different concentrates that vary quite significantly in terms of their mineralogy and their grade. So as a result of this, they need something that is quite robust and will offer the flexibility to treat very different concentrates. And in that particular jurisdiction, leaching has been identified as the optimal process for extracting that copper, and specifically the Albion process for Hudbay.
So how do you, again, just because we do have the time in the long form, what are some specific challenges that a project like that encounters? How does those initial conversations start when you're looking at a project like that, especially with its variations?
So obviously, as I said, with this one, it is the fact that they will be mining from different zones, and as a result, there will be significant variation in the feed in terms of the mineralogy and the grade. So we're looking at something that needs to be very robust, and I suppose part of the appeal here is the simplicity of the process, but at the same time, because our technology is modular, it will actually allow them to build the plant in stages so they can actually balance copper production on site with treatment in the local toll market as well. As a part of these discussions, obviously I mentioned the sort of economics is always a consideration in any project. So when we're talking with clients and when we've been talking with Hudbay, something that really stands out for them is the fact that we have good control over a number of parameters or leaching conditions, and as a result of that, we're able to significantly reduce the neutralization requirements downstream of the leach, which substantially lowered the OPEX.
And I guess in that way, it substantially lowers the CO2 that you generate from neutralization and from a lot of those other aspects of the process. Yeah.
So beyond just economics and moving into ESG. And I guess stemming off that, and this is not necessarily unique just to Hudbay, but when we're talking with clients, we're always looking for opportunities to leverage either natural properties of the ore or, in this case, a byproduct of the leach. So we've identified an opportunity to recover elemental sulfur, which, as I said, is a leach byproduct, and to actually use that to generate acid and feed back to the head of the leach. As a result, we're significantly reducing the amount of fresh acid that would need to be purchased to add into the acid leach, and again, lowering OPEX overall.
What is the educational level of your clients when you're first coming to them? And I don't know who wants to take this one, but when When those initial conversations start, are they usually aware of the technology, understanding how it's going to be used, understanding its scalability? Where are they at in those initial stages?
I might grab that one. In this case of Hut Bay, when we look at that one, the key connection that we had with that client was the fact that we'd already been speaking to them on the concentrator side. So our Jamison concentrator group had been speaking to them about, okay, to take this ore, to make this concentrate, what is it that we're going to be working through and needing to be done? And then it came to the point of, we've made the concentrate, what do we need to do next? Yeah. And that's where the conversation started. But actually, when you consider that case, that is typically the customer, or the people that we speak to, are the technical people on site who have mainly a concentrating background or background on froth flotation. And then they know that they need to make a further processing step. And they do look and reach out, and like a lot of them would have covered hydromet in university, or looking at, okay, is there a smelting route? So that they have an awareness of it. But for us, a lot of our outreach to clients is about being able to educate them. I mean, very similar to this session that we're doing here, which is about knowing, hey, the Albion process is there to provide this solution for industry, and come talk to us further, and being able to bridge that gap of, well, okay, what from hydromet to specifically what the solutions are possible with the Albion process itself.
Where does the technology go from here? It's fully commercialized. It's been in the market. Obviously, demand is going up. But what are your plans for it? What do you think the industry demand will get to for it?
I might take that one. I mean, from our perspective, really what we've looked at pitching the technology for, and where we see it growing even more going forward, is where we have these deposits where clients are wanting to meet their ESG targets, or have to meet the legislative requirements of that local jurisdiction to produce a final product in country. That's going to be the mainstay of our market. But really what we've proven with all these plants and these sort of more complex interactions, I mean, we probably do 20 to 30 sets of, I guess, that fast fail test work each year. And that's being done for the last 20 years. So the amount of knowledge we have on how to apply the process has meant now, we're looking at lithium, we're looking at some of the battery grade metals, and that need this same sort of approach to look at a different way of applying the leaching. So for us, it's only upwards from here when we look at where we're going to apply the technology. And when we look at the past couple of years, we've got much bigger operations that are now looking to use our technology, where previously some people would have thought it was niche, but now we were actually moving past that. I mean, earlier this year, we commissioned a plant within the Glencore group, but looking at even just adapting our understanding of hydrometallurgy. We took our oxy-leach reactors, and we're now making a copper sulfate product for one of our concentrators to use as reagent. And we're doing that by treating a waste from one of the other Glencore sites. So we've really looked at how we can really adapt our approach. And that, to me, is where it's really expanding the market for us.
Has there ever been a brighter future for mining, do you think? And anybody can maybe answer that from each of your different perspectives as well. From my perspective, I see that it never has, just the demand for it has never even been close to this. Yeah. What are your thoughts on it?
I might invite Rebecca to go first.
I was going to say, I agree. Like, all we're seeing is increasing demand for commodities. So increasing opportunities for us to introduce our technologies, but also expanding opportunities. So Senko's alluded to sort of moving into recycling and different ways in which we sort of consider mining and how we apply our technologies. So there's lots of potential, and it's only growing.
Yeah, I suppose I'll add to that. I mean, you asked about mining, but I suppose if you don't necessarily look at it as mining, you look at it as mineral processing, or maybe you include urban mining in the term mining, then that's what's really changed and opened up like a whole lot of other options that maybe weren't at the forefront, but as time goes on, they're becoming more and more important with this recycling thing. And the thing with recycling, I suppose, is we've been we've been treating sort of minerals that we're familiar with for a long period of time now, but the recycling means we've got some really different feeds and some really complex feeds, and they often need sort of quite a lot of processing steps to untangle, I suppose, all those metals and turn them into saleable products again. And that's what's really interesting, and I think that's what's going to be great for the future.
Another question that has come to mind while doing this interview is I'm not guessing anybody's age, but we get a lot of people who've been in the industry for they're sort of retiring, and that's a lot of the leaders that will come in. But having the three of you on, I wanted to ask, how do you think the industry can attract that next generation of professionals into the mining space? Because it has the technology, it has you all over the world it's operating. There's a ton of opportunity, a ton of demand, good paying jobs. But I still talk to people and they're trying to figure out ways to attract people. What are your thoughts on how to get that next generation into the world of mining and mineral processing?
Our approach actually has been putting boots on the ground with the universities. So here within Brisbane, we've got 3 universities that have chemical engineering, or I guess feed-in programs to the mining and metallurgy industry. And so we've been quite active sponsoring the student societies of those universities and having, hosting, like Laurie went to a high school a couple of weeks ago. Rebecca hosted I think a second-year class of thermodynamics students in the engineering faculty here in our office to talk through what we do and some of the aspects. I mean, I've always felt when I consider what we do is just demystifying that and actually putting people in front of those students and having them actually meet and talk to us both in a social setting as well as through understanding what we do. And that to me is the approach that I think is the best way that we can act to try and push more people into the industry. I think, though, that mining companies as a whole, I mean, we see it here in Australia. It must be in other parts of the world as well, that you look at a lot of the advertising. I mean, Glencore itself is now advertising on TV and YouTube commercials here in Australia about the contribution that the resources industry provides to everyday products such as phones and the electricity of the cars. And I think that's the requirement of mining companies, but then us in terms of the teams or the professionals, it's getting that connection in with the students. And I guess not just universities, as I mentioned, Laurie went to high schools. I think that's one of the key areas we're expanding into now. And Glencore as a whole is pushing that in terms of secondary schools within Queensland. We've got a partner here in Queensland where we've got a hosting of various Glencore people from multiple disciplines in the school system across the state. I think it's programs like that really help.
I was going to ask I'm really interested to hear the reaction and just some of the feedback from the high school students.
Yeah, that was actually a really good experience, and it's not just me. We've got a number of people from Glencore Technology go out to the high schools, and I suppose we work with students on different STEM type activities, and we always seem to get really good engagement. I suppose because they get a different point of view than just their normal teachers. And when we work through these STEM type experiments and whatnot, I find that us as metallurgists are able to give like a really good explanation of exactly what they're seeing. So the students always seem to be really engaged. And I suppose, encourage them when I go to these events, encourage them to go to as many as possible, because when you're in high school, you don't necessarily know what's out there in the world, and you're sort of making decisions. You're making decisions for year 11 and 12 for what subjects you're going to study so that you can move into university, so you can get the degree you want to go into the career you want, and you don't necessarily even know what jobs exist at that point in time. So when I go out there, I always try and encourage the students to go to things like that, just so that they can learn, what jobs exist and what things they might be interested in. So, yeah.
I will say,
jump in there. Sorry.
Go ahead.
Just, I actually went to my son's grade 3 class and took apart an iPhone for them and showed them where all the metals are and said, this is how you recycle them. And I had really great feedback. Had a few other teachers from other grades come in to watch as well. And
Yeah, I'd watch that.
from the parents as well, just to be able to say, hey, it's good for their children to understand that what something is and what it's made from.
Yeah, it really stands out to me. The reason I sort of latched onto the high school thing is because I remember years ago, I took my niece to an event, and I wasn't ready for how engaged she was. She was asking people great questions, and they were but she's also young. She can absorb information. She doesn't have as many layers as you get older and older. You get all these layers of life on you, and she was just soaking it in. And she was like 14 or 15. And it seemed like I've seen people that are in their 30s not be asking as good of questions. And so I think it is really important to start talking to people, these kids that are at that age where, that mining just is not on their radar. You don't see a mine. If you're going to a high school, you've never seen one.
No, that's right.
Exactly.
Okay. Thank you, everybody, for coming on the show today and joining us and organizing this. And we're traveling all over Australia trying to do this. So thank you for taking the time. I hope we're going to be doing more with Glencore Technology because, we're just putting a small dent in all that you offer. But I really do thank you for taking the time and doing this interview.
Thank you for having us.
Thank you very much.
Yeah, likewise from our side. Thanks very much. It's been a pleasure, and it's been really great to talk to you about what we do from the technology side, but also some of our other initiatives. And yeah, it's exciting. We look forward to working with you all again.
Thank you.
Thank you.
And thank you, everybody, for watching. We're going to, of course, have lots of links to some of the things that we talked about today on the show in the description. And make sure to follow Glencore and follow us and keep supporting the show so that we keep making it. It's just been unbelievable, the amount of information we've been able to share about mining and then the support we've had coming back the other way from the audience. So thank you, and thank you for all the people that support us. We will see you on the next episode of Mining Now.